Find two explicit functions. So this is more of an exploring activity. Finding two explicit functions means we're going to kind of solve for y and make this calculator ready so that we can have two separate actual functions, because this in and of itself is not a function. It would fail the vertical line test. So we're going to write it as two separate functions by solving for y. So if we add our x squared over, divide by 9, and then square root both sides, we're going to get y equals positive root 1 plus x squared over 9, and also y equals negative square root 1 plus x squared over 9. So as individuals, those each individually are functions. When you plot them together, though, it's not. So I'm going to square root of 1 plus x squared over 9 negative square root 1 plus x squared over 9. So zoom 6. Okay. So those are the two explicit functions. We sketch the equation. We can either sketch it here. We'll sketch it on here so we have explicit. Individual. That's just kind of a math word. You don't need to overlook into it, but so then this asks us, and again, this is more of an exploring type thing, to differentiate each one individually. So given that this is a function, I'm just going to differentiate it as I typically would. So I'm first going to rewrite it as 1 plus x squared over 9. Would you rather write that as 1/9 x squared? So it doesn't look like a quotient rule type of thing. I'm going to do that. I'm going to do 1/9 x squared to the 1/2 power. So now when I differentiate that, I'm just going to do y prime. I'm going to follow a power rule first. So what is that going to look like, Haley? To the negative 1/2. And that needs to be followed by what? Yeah. Not product. Right. So that's a chain rule. And what rule does that, finding the derivative of this, require? What times what are you seeing? Okay, but when 1/9 is a constant, you don't want to do the product rule. Just the plain old power rule. Yep, just bring that 2 out in front. So 2 times 1/9 will be 2/9 x to the first power. And that's just the derivative of what's inside. And there's nothing else inside of that, so we're good. So when I clean this up, this 2 and this 2 will cancel. And this guy's going to move to the denominator. So it'll be x over this 9 will be on the bottom with radical 1 plus 1/9 x squared. So the other function is going to be pretty much the same. Will the answer just be a negative version of that? Yeah, not sure about that. So it might be. What's your logic? No. Do you see why? Now that I write it this way, I'm still going to take my 1/2 out in front. It would have only been the negative 1/2 power if this was in the denominator and I was taking it out. That negative is a coefficient on still something that's raised to the 1/2 power. Looking at the picture, do you think the derivative of one of these is just the negated version of the derivative of the other? Probably. It definitely looks that way. So, I don't know. The more I think about it, the more it's, yes, it will just be negative, but I understand just the double checking to be sure. So again, with the derivative, power rule first, negative 1/2 in front of the parentheses, being raised to the negative 1/2 power, times the derivative of what's inside will be 2/9 x again. Again, your twos will cancel, and then you see it unfold the same way, except for there's just a negative in front. Okay, so if we do it as two explicit equations, we get two different derivative equations, one for the top part of the hyperbola and one for the bottom. C wants us to find dy dx using implicit differentiation, the way we learned how to yesterday, and then we're going to kind of compare the results. So what is the derivative of 9y squared, Nathan Z? What would you do for that? Perfect. What would you do for the next term? Zach. Yep, minus 2x equals Winter? 0. What would you do next, Jalen? Good. Alyssa, what would you do next? And so our answer is x over 9y. Once you simplify that. So, what do you make of that? Do those look the same to you? Yeah, there's an argument here. We could make them look exactly the same. How, Connor?
Because y equals the square root of 1 over x squared over 9.
Does everybody see that now?
Because y equals that, you can just substitute it.
Right. So since y equals one of these or the other one, the derivative of this is going to be x over 9 times that radical, which would be in line with this one. Or x equals 9, the derivative equals x over 9 times this radical with the negative sign, which would be in line with that one. Do we follow? So just kind of pointing out that connection there. Any questions on that? That's more of an exploring kind of thing. Okay? We're going to use implicit differentiation and then just evaluate the derivative at the given point. So why don't you go ahead and do these on your own. And Raise your hand if you're done. Raise your hand if you're stuck. What's your question, Nathan? You good? All right. Enough of you are still working. I'm going to give you another minute, and then pick 3 numbers, Stephen, because we're going to grab some papers.
7, 11, and 19.
The 3 pictures don't work. Steven, do you believe that? You picked those 3, all right next to each other.
That's it.
Haley, Jalen, and Winter. All right. Ooh, we can play teacher, though. Maybe. This person got 4√6/6. Raise your hand if you agree. Okay, let's play teacher then. I see. We left off at Taylor.
So you're not supposed to square the dy dx, you're just supposed to have it 3y squared times dy.
Correct. So the derivative of y cubed is 3y squared, followed by the dy dx. We don't square the dy dx. Is that clear? We all learned from that? Good. Okay, this person got 1/3. Raise your hand if you agree. Good. Okay, so I'm not going to let you look at that too long. This person got 1/3. So, all right, so there's the 3y squared dy dx minus 2x equals 0. We isolate, divide over the 3y squared, and there's our derivative. We just plugged in 2 for x and 2 for y. Correct? Very good. Let's go to this next one. This person got √2/3. Raise your hand if you agree. Not that I'm rooting against you 3, but yay. So let's take a look, see if we can find their mistake. Kendall?
They have like the rate equation, but they type in the numbers wrong. They're trying to pile over 3 as 1/2. It's trying to pile over 3 as 5.
Correct. All good. Your values are off. Nice job, Kendall. So that's not a calculus issue. That's so for me, that's good. This one got root 3 over 2. Raise your hand if you got that. Okay, let's play again. Steven?
The last step, they did divide subtraction correctly.
Correct. You're right.
They should have multiplied 1/2 times 1.
Right, so they canceled out their 2's, which was smart, but then it's keep the 1/2, change division to multiplication, and flip radical 3 to 1 over radical 3, which would have been 1 over 2 root 3. Again, good for me, not a calculus mistake. Your calculus is exceptional, okay? It's just algebra. So that's Steven. Wow, we're going to see. This is good. Okay. Shh, don't tell. We want someone to get. Point. So take a minute. People look stumped though, Jalen.
Yeah, I mean, I didn't even do anything.
Is Ellie here? Oh, there you are. Like, wait a minute. Ellie?
She left out the y.
Yeah, way up top. Forgot the y. Derivative of cosine is negative sine of y. And so that was just careless. Good job, Ellie. So what was the answer?
Oh, what about the axis or stuff?
She took the sine of the
I distributed the x.
Oh, I didn't look anywhere past the first thing. Once I found, it took me a while to find it because I wasn't. What are you saying she did, Josh? Here to down here? Oh, yeah. And that x is a coefficient, not something that we're supposed to be taking a sign of. Yeah. So it should have been negative x sine y. All right. Good. Any questions on those?
The answer is right here.
1
1 over
over 2.
2 root 3, which would be root 3 over 6. Yeah. If we I'll let you do the honors. If we rationalize. Okay. So again, a skill, writing the equation of the tangent line. Let's do A together. So we have a cissoid. You'd have to fact check me on the pronunciation on that. But we are going to try to write the equation of the tangent line at 2, 2. So it looks like it's going to be something like that. And we need a point to write a line. We need a point, which we have, 2, 2. And we need a slope, which we have to find by deriving. So if I go to find the derivative here, what rule are you going to apply first, Kyle?
Well, I would distribute it first.
Okay, that's fine. So he went 4y squared minus xy squared equals x cubed. That's fine. And so you're just going to, now to do the derivative, you're just going to do what?
First take the power rule.
Okay, so tell me what to write. Keep going. So he's doing the product rule here. Really careful with parentheses here. Because the product rule is ends up being a binomial, something plus something else. When you have a minus sign in front, keep it in front, right? And then the minus is out in front, and so when you're doing the product rule, you can just do the first as x and the second as y squared. So first times derivative of the second plus second times the derivative of the first, which is just 1. And you can close it there. Do you follow? Any questions on that? Equals Stephanie? Good. So, gosh, I really don't, oh yeah, I do need to distribute that negative sign. So I got to distribute the negative sign, and see that other dy dx for the moment. Minus 2xy dy dx minus y squared equals 3x squared. What comes next, Zach? Add the y squared over, so I'll just do that. And then next, keep going, Zach. Very good. So I'm left with 8y minus 2xy in parentheses. And then divide that over. So we have our derivative, but then in an application problem, you kind of got to remember where were we in the whole context of this problem. So what do I do next, Ellie? Plug in 2, very good. And when we do that, we're going to get 3 times 4 plus 4 over 16 minus 2 times 2 times 2 is minus 8. 12 plus 4 is 16. Over 16 minus 8 is 8. Oh, would you look at that? We got a slope of 2 as well. Were we expecting a positive slope? Yeah, so that's just something that you could just check with in case you made a mistake. And then we're just going to write the equation of that tangent line. So y minus 2 equals 2, x minus 2. Done. Did I do something wrong, Kendall? Oh, then I probably did do something wrong. Oh, let's play teacher. Okay, so if you do go right to the product rule, and you're treating the first term as negative x, is that what you're doing?
No, like I just think like
Oh, you did it from the start.
yeah.
I see. Will you bring it to me? I know, that's good. Sort of. Good for everyone else.
Yeah, for me.
No, but you'll learn from it, so it's good from you. We gotta see the glass half full. All right, so she's saying she didn't distribute like Kyle did. So and this is kind of where I thought I didn't mean to be using a leading question. I was looking for Kyle to say that when I asked him the initial question. To start with the product rule. So his first would have been 4 minus x. She's got that there. Oh, I shouldn't talk you through it. I'll just let you look. She rewrote the problem down so I can kind of do this. Scroll in. There's her original. Riley, did I ask you to play teacher yet? Oh, you already did. Kyle. Haley.
I think she's subtracted
Correct. Real small, right here. Should have been added over, which would make that a plus. Which would make that a plus, which will change the whole game. So now she'd have 12 plus 4, and there we go. So you obviously you did it right, calculus-wise. Okay, and the last one. Do we want to do it on our own and play teacher, or let's do it together? Because I don't know if we'll have time for all that in case anything else comes up. All right, so we'll just go around the room. Steven, derivative of this.
It is 14 ninths.
Second term. Lily, go ahead. Tell me what to write. Mm-hmm. What are you debating between?
Well, I don't know what to do with radical 3.
Just the radical 3?
Is it just negative 6 radical 3?
Yeah. Yep. So let me, for those of you who might have done it differently, explain what she just did. We got the 14x. She treated this term and did the product rule. Her first being negative 6 root 3x, and her second being y. So here's her first times the derivative of the second. Ruined our game. She did forget her dy dx. Plus second y times the derivative of the first. Good? We keep going. What would the next term be, Nathan Zorn?
26 y divided.
Okay, the next term. Haley? Good. Equals 0. Is this a teacher opportunity, Stephen, or you have a comment?
That's a very good question.
Okay, go.
So, I get that when you're doing explicit differentiation,
Mm-hmm.
you're supposed to change all the y's to dy's, okay? That's what you do. But I don't really get why.
Because you're taking the derivative with respect to x. So any variable, if a t comes up and you're trying to take the derivative of a t term with respect to x, you'd need to follow it up with dt dx.
Okay.
And even when you're taking the derivative of an x term, you can technically follow it up with dx dx. But that's just one, so there's usually no point.
That might be so.
Okay. Josh?
When doing the product rule, could you just keep the negative 6 radical 3 on the front?
You could. And then in parentheses, just to power, that's probably what I would have done, but we went with Lily's, that's fine? Is that what you were going to say? Yeah, so they're saying if you want to keep that constant, negative 6 root 3, and then a big set of parentheses for the x and the y. So now from here, if let's say I'm going to move these guys over. I'm going to keep my 14x. I'm going to keep negative 6y root 3 on the left equals. I'm going to add my 6 root 3 x dy dx. Be careful that you know that that x is not under the radical. Okay, we can be sloppy with the size of our radical sign. It can throw everything off. So that radical was only over the 3. So I added that over, and I'm also subtracting over the 26y dy dx. I'm going to be able to factor out now. And again, some of you can do this all in the same step, where you can kind of envision that you're going to factor out a dy dx, and what's going to be left is this 6 root 3x minus 26y, and you realize already that you're going to have to then divide that over. 6 root 3x minus 26y, and there's your derivative. So the point we're supposed to be using is root 3, 1. The slope we're supposed to be using, we just have to plug in a root 3 for x and a 1 for y, which is nice. What's 6 root 3 times root 3? 18. So your slope ends up being 8 root 3 over 18 minus 26 is a negative 8. Negative radical 3. That worked out a lot more nicely than we would have initially thought. So y minus 1 equals negative root 3, x minus root 3. Oh, not till APs are over. You can't bother.